Hello everyone. Welcome to the e-learning space of Data Science for Public Policy. This video is brought to you by the DSPS Data Science and Policy Studies program under the Chinese University of Hong Kong. This video is supported by the CUHK Courseware Development Grant Scheme. Our topic for this video is about hypothesis testing. We're going to go through hypothesis testing difference in mean and some applications using Stata. First of all, let's go through the definition of hypothesis testing. There are many problems where we need to decide whether to accept or to reject a statement about some population parameters. This statement is called a hypothesis, and the decision-making procedure regarding the hypothesis is called hypothesis testing. To perform a test, we had to follow the below procedures. So first, we have to set the significance level alpha if not already given. If you have no idea what alpha you should take, a common practice is that you can take alpha as 0.05 or 5%. That means your significance level is at 5%. And this will serve as a cutoff for you to measure whether your p-value is significant or not. Second, state the appropriate hypotheses, null and alternative. So null hypothesis is usually the more usual case, and we sometimes call it as H0 as well. Alternative hypothesis is a case opposite to the null. Sometimes we call it H1 or HA. Third, compute the appropriate test statistic based on sample information. Depending on what you want to test, you need to use different test statistics. Some common tests are t-test, z-test, and f-test. In these cases, we will calculate t-statistic, z-test statistic, and f-statistic respectively. Fourth, sketch the acceptance and rejection regions. Sketching here means the picture in the previous slide. So here on the right-hand side, you can see, depending on whether you want to do a right tail test, left tail test, or two tail test, then your acceptance and your rejection region would be different. So if you only want to test your value being equal to the population value or not, then it means either bigger or smaller than the population value means it's not equal. In that case, we are going to use the two-tail test, which is the one at the bottom. So you can see, when your value is different from the population parameter, then your value is going to fall inside the red region, which is the rejection region. And then the white one would be the acceptance region. So going back to step 5, so we will have to examine whether the calculated test statistic falls in the acceptance or rejection region. So here, to determine the red and the white region, you have to find the critical value of your test using your degrees of freedom and your alpha level. So basically, you have to look for a critical value which determines the cutoff, also the boundary between the red and the white region, and then you compare the critical value with your calculated test statistic and see whether your test statistic is deviated far from 0 or not, and then you are going to decide whether your test statistic will be located in the red region or not. So the last one, after you confirm the location of your test statistic, then if it's inside the white region, the acceptance region, that means the null hypothesis is true. And then your null hypothesis is your conclusion. But if your test statistic is located in the rejection red region, then the alternative hypothesis would be preferred over the null. So your alternative hypothesis will be your conclusion instead. So let's talk about testing difference in mean. Assume we have two data sets. They are two normal populations with equal variances. If we want to test whether the mean of the two data sets are equal or not, we can first estimate the population variance by the below formula. Here, the S refers to standard deviation. So S to the power of 2 is the variance. N1 and N2 are the sample size from the first and the second data set. So you can define one data set as the first one and another one to be the second one. It doesn't matter which one comes first. After calculated the SP squared, which is the population variance, then you can calculate the t-statistic using the formula below. For information, we can also say we're going to do a t-test in testing difference in mean. At the top of the formula for t, we first do a subtraction of mean 1 minus mean 2. Then this value will subtract a thing called mu1 minus mu2. So this mu1 minus mu2 means the true value that you are expected to see in the population. For example, if you want to test whether two means from the two data sets are equal, then mu1 minus mu2 would be 0 because you expect them to be equal under your null hypothesis. So mu1 minus mu2 here can be any value that you are expected to be the true value in the population. So let's move on to some application using Stata. Again, we're going to use the Hong Kong visitor arrivals sample data, which is an open data source provided by the Hong Kong Tourism Board. If you're interested in how we get data, please refer to the first e-learning video on descriptive statistics. Today, we're going to use two variables. One is the total VA, the monthly total visitor arrivals to Hong Kong, and another one is the total VA USA, which is the monthly total visitor arrivals only from USA. Again, like the previous two videos, we first load the Excel file from our local computer. Then we're going to do the TS set time, which to let Stata recognize that the time variable is time dependent. And then we're going to create a new variable called period, which defines 3 different periods of time. They are the normal times, the extradition bill, e-bill times, and the COVID times. So first we can plot a box plot by typing graph box. Box is the graph type, and the variable of interest. Right now we're interested in the total VA USA variable. And after the comma, we are going to specify over period. So this is going to let Stata know that we're going to group the data by period 1, period 2, and period 3. So here we can see the box for period 3, COVID time strings into a line. That means the data spread is not as wide as the other two periods. And the visitor number really dropped a lot when COVID hits us. Next, here we can see the first 3 lines of the code, Gen USA VA1, VA2, VA3, are creating 3 different variables. So these 3 variables are grouping the total visitors from the USA under the 3 periods, normal times, able times, and COVID times. So after we generated 3 different variables, next we're going to do a t-test by typing t-test USA VA1 equals to USA VA2, comma, unpaired. So here we're testing if the number of USA visitors are the same during the normal times versus during the e-bill times, period 1 and 2. The unpaired option here is selected because the visitor number under the 2 periods are not related. So let's move to the table. So the table shows some descriptive statistics of the 2 variables, USA VA1 and USA VA2. And on the last row of the table, we can see there is a variable called diff. So diff means the difference between the 2 variables. Below the table, we can see we are testing the null hypothesis that the difference between the 2 variables are 0 or not. So the t-test equation here should be the one on the right-hand side bottom. So you can see there is a text box. So here, the t-statistics should be calculated by diff minus 0 divided by the standard error of diff. So that is, so I copied the values in computer for you. So the t-statistic should be 3.9875. And you can see below the table, there is also t equals to 3.9875. So basically, Stata calculated this for you, so you don't have to do it by yourself. And depending on your alternative hypothesis, so you might have a different p-value. Here, since we want to just to know whether the 2 variables are different, so we're going to use the two-tail test, which is the alternative hypothesis as the middle. So the corresponding p-value for the alternative hypothesis would be 0.002. If we take the significance level to be 5%, then a p-value lower than 0.05 is considered significant. And therefore, here the difference between the two variables is going to be significant because 0.002 is smaller than 0.5. And then we're going to conclude that we should take the alternative hypothesis, meaning that the difference between the two variables are not zero. And lastly, at the very bottom of this slide, we have a line of code that teaches you how to plot the scatter plot at the right. The scatter plot was taught in the previous e-learning video about confidence interval, so you can go back there to learn more about plotting. So next is going to be similar thing. We want to t-test the visitor arrivals from USA during period 2 EBIL times versus during period 3 the COVID times. So again, we're going to type t-test variable of USA VA2 equals to USA VA3 and then unpaired. And then directly under the table, below the table, we can see that the t is calculated as 14.7243. And again, if we only want to know whether they're different from zero, we can use the alternative hypothesis at the middle, which is the two-tailed test. And then the p-value under it is 0.0000. So if we're using 5% significance level again, then this is for sure lower than 0.05, and that means the result is significant. So now that means the difference between USA VA2 and USA VA3 are significantly not zero. So we can conclude that the number of visitors coming to Hong Kong from USA during the EBIL times and during the COVID times are significantly different. And the visualization on the right-hand side, the scatter plot also shows, you can see when it's COVID times, then the visitor arrivals are almost like approaching zero. Lastly, COVID-19 is the most significant reason for bringing the tourist industry to a standstill. The impact on US tourism has been large. US inbound tourism will likely remain subdued in the near term, but may begin to recover later when vaccination program in Hong Kong further improves the current situation. After the COVID-19 situation are put under control, it is also suggested that tourism promotional campaigns may restore US travelers' confidence. So this is the end of today's video sharing. Thank you.